Thank you everyone for being here. Very glad, and it's a pleasure for me to open this second day of the annual conference from EASA, annual safety conference, very important term, and even when we wander into the direction of artificial intelligence, that's the driving factor. I followed with great interest the presentations and discussions yesterday. It was great time to reflect, and it was difficult to keep the pace with counting the number of times artificial intelligence was mentioned. So we see AI is really a multifaceted and powerful enabler which can help us in numerous applications to have a huge potential to contribute to safety. But at the same time, it's raising important challenges. And interestingly, it's not only on the technology side, but it's definitely also on the human side, as was really highlighted yesterday by Florian. So the roadmap that we started in 2020 is at the heart of this transformation, embracing a human-centric approach to AI trustworthiness. Since 2019, the human-centric approach has been our guiding thread, shaping every version of the AI concept paper. And we took a gradual approach, slicing the problem and the challenges in three subsequent, or I would say consecutive levels of AI. And whether we want to classify an AI system level 1, level 2, or level 3, a same system, a strictly identical system, depending on its usage and the way it is embedded in more advanced automation, you may have a very different leveling, let's say, for a strictly same system. And that's why it requires a careful consideration and analysis of the concept of operation from the start that is presented by an applicant. And that was mentioned by Alain yesterday. It's the first fundamental principle of the AI guidance that EASA has laid down in the concept paper, to have a clear concept of operation, what we call a CONOPS. This defines not only the identification of the end users, of the high-level tasks that are performed and supported by the AI, but also the operational domain of use, and also the interaction, the essential interaction between the systems and the human or the humans, end users that are involved in the operation. So CONOPS is not new. I'm not trying to invent a new term here. It's the same term as we know, but it's truly, let's say, raised and leveraged by new type of applications, like computer vision is one example of them, and also new type of operations. I'm thinking about innovative aerial services, for instance, that makes it critical to use this type of tools, known tools, but we are in different CONOPS today in most of the applications we received on the AI side. So with that in mind, fasten your seatbelts and let's explore the three pivotal levels of AI development in aviation, each pushing us towards a future where human expertise will be seamlessly integrated with more AI collaboration. So let's take off and start with what we call human assistance, level 1 of AI. At that level, the role is straightforward but crucial. It's assisting humans. AI processes, for instance, vast amounts of data beyond human capability, provides real-time explainable insights that can boost decision-making, safety, and also efficiency. The end user, pilot, air traffic controller, whoever is the end user, stays fully in control, while AI enhances the situational awareness and the safety. EASA's machine learning guidance ensures that the AI systems are built with strong data management, verified learning, and transparency. That's fundamental principles, and in a nutshell, to put it in a couple of words, the level 1 is trying to reach, on the system level, a confidence that the AI-based system will perform as intended at the right level of performance. This is obviously a need not only for level 1, but for any of the subsequent levels that we will discuss today, but definitely that's a foundation. Without surprise, the current aviation standards fall short when addressing machine learning's unique challenges. EASA's learning assurance concept was built to fill this gap, and some still believe that machine learning models should be treated as traditional standard software. And clearly, unlike traditional software, at the end, it is software. So we still need the existing principles, clearly. But we have machine learning prediction that depends on data, and that's the key. So without a robust and solid data management step, no AI application will be worth anything in terms, again, of intended function and performance. And this calls also for certain properties we give to machine learning models, like stability, robustness, and most of all, generalization capabilities. That's a new term. If you think software development assurance, this is a term that we don't have in our guidance so far. So with level 1, we're already seeing a transformative change. At this level, I would call it more an evolution than a revolution, if we are in level 1, because we have successfully managed, with the guidance laid down in the concept paper, to integrate those new principles of learning assurance into the existing development assurance and certification frameworks that are already in place. Some AI solutions are already under certification using the EASA AI special condition that was raised in 2022. We are currently working on an update of it to leverage the new issue of the concept paper that was published early this year. And we already have systems like, for instance, traffic detection, like you can see here on the screen, under visual flight rules, that are using machine learning to enhance non-cooperative traffic detection. So this is a safety net, a safety enhancement capability for general aviation massively already today. That's something we need to take into account at the certification, yet again, putting the focus on the capability to perform, for a system to perform well. There are some challenges. I'm not saying we have done completely the work, but definitely on this notion of AI assurance, we have a solid ground of objectives in the concept paper. We have challenges more on the identification of practicable, meaningful means of compliance sometimes to challenging objectives. So that's something we are still working in research, but also in the standardization working groups to elicitate, but we are on a good path with that. There could be, of course, this is only one example. In ATM, you have a lot of possible applications like 4-day trajectory, calculation optimization, support to flow management, support also to conflict detection and resolution. In maintenance, in training as well, we are working with CAE on using AI in the enhancement of pilot training with gaze monitoring, for instance, all, again, totally under human control. If we move one level up to what we call human AI teaming, here you can independently, or the AI can independently handle tasks or even make decisions. That's a strong barrier compared to what we call level 1. Yet, the human operator remains fully in charge. The challenge is how much authority we can give and release to the system, and how, at the same time, we keep the human oversight safe and effective. So that's where the EASA guidelines focus on maintaining this balance, ensuring full accountability and control oversight of the human, while requiring applicants to develop safe and trustworthy AI teaming assistance. And again, here, to put it in a couple of words, what we look for with the human factors for AI building block of the EASA AI roadmap is to get to a level of confidence in the safe interaction with end users, to keep this capability of interacting safely, despite, again, a ConOps that is pretty different from the level 1 type of ConOps we are used to manage. This requires the development and giving flesh to certain principles, like, for instance, operational explainability, which is a capability to have timely, at the right level of detail, explanation of what an output is of the AI-based system at a possible critical time. And we have also the human AI teaming concept that took really a large portion of place in the issue 2 of the concept paper through defining roles and task allocation, but also considering the error and workload management with a different perspective, and the interaction being also possibly customized. For an AI, you need to adapt to specific various operational contexts, and that's something to take into account as well. So this balance between AI and human authority is what makes level 2 more revolutionary than what I was mentioning in level 1. Introducing the AI-based system as a team member, not as a sole assistant. Some may think that this is personifying, in some way pushing to a personification of the AI. I would say not at all. Releasing some authority is something we already do to systems in aviation today. The point is to distinguish between two aspects, which is authority and responsibility, let's say accountability. And this is where At level 2, we have clarified, and it's probably something to be also considered in the rulemaking aspects. We have considered the full responsibility on the human and really keeping the human in the center from a responsibility, but also control and oversight perspective. Of course, one doesn't go without the others. So there are also a number of challenges remaining for this level 2 guidance, which demands exploration of multiple use cases, deeper investigation also through research and innovation projects. We have the ambition to start a project like the MLEAP project. MLEAP was tailored to push the means of compliance on the side. It's a Horizon Europe project that was financed by Horizon Europe to push the AI assurance means of compliance. We have the ambition to start a similar project on the human factors for AI aspects, to push and investigate topics like shared situational awareness, seamless bidirectional and multimodal communication. That's all what AI can enable today, and robust failure management for both the AI and the human team members. So that's where we are, I would say, at level 2. And I think the picture that I chose here illustrates the teaming, maybe from a different perspective in maintenance operations. You can already have drones operations used in visual inspection. That's not like saying it's science fiction. It is existing, but the question is how much decision-making capability you may give to such a drone. Do you want to verify absolutely each and every image that is taken by the drone on a possible damage? This is all the questions that are leveraged by level 2, so it doesn't have to be extremely advanced in terms of automation, beyond, I would say, reasonable ground that we have today, but it raises, again, a lot of questions on the interface, and again, also on the way we rely on the machine to perform as intended. That brings us to the more futuristic but also nearly realistic view of level 3, which is called advanced automation. So the picture is a ChatGPT generated picture, so definitely I don't claim this is realistic, but the fact to have drone delivery or delivery of parcels embedding drone is really becoming a reality. And that's where we are moving into AI-managed operations with limited or remote human involvement. That's a crucial barrier, I would say, again, between level 2 and level 3. And don't see level 1 to 3 as a continuum. We don't claim that someone has to go through the steps. If you think this type of operations, if you think use space, we will land actually in a level 3, if, of course, it leverages AI, pretty rapidly in terms of concept of operation. So think about fleets of drones for delivery in urban environments, but don't be mistaken, that doesn't mean autonomy. Autonomy, we carefully defined it, the term in the concept paper and in the roadmap, to be something much beyond what we consider a safe subset for aviation. So today we are not looking at this. We consider that level 3A, 3B as was defined is kind of a boundary that doesn't necessarily leverage the full potential of what AI can do, but that's fine, because that's exactly where we can consider today that the boundary of managing safety as it is today is still possible. And that's really a very important statement. So autonomy is not what we are talking about when we say advanced automation. And let's dream for level 4 sometimes in a few decades, but that's not the focus of the roadmap today. The challenge yet at level 3 lies in maintaining this notion of human oversight, even though the human operator may be remotely involved, or sometimes, why not involved at all during operations. So more precisely, if I focus first on remote monitoring, which is corresponding to this level 3A, the challenge lies in managing how situational awareness can be transferred back to an operator that was not involved in the early stages of the operation. That's in itself a huge challenge, and I think everyone operationally thinking here in this room will fully agree. We have already examples, for instance, in the automotive or in the military domains, where they already investigated, actually, pretty advancedly, this type of considerations of how to transfer situational awareness, but that's another piece of cake, let's say. Shared situational awareness is a difficult topic, but transfer of situational awareness is a major challenge. We are still in the process of defining the design principles that could accompany this level 3. We do it under the scrutiny of our EASA scientific committee. We have an AI task force that has been started, and we see today jointly with them three main principles that needs to be carefully kept under the control. So first, the full control of the development phase. It looks like implicit, it is implicit in everything we do in aviation today, but with AI, you may also, why not, imagine using tools to develop AI. And that's another thing where we have to be careful, put the right boundaries to make sure that the development phase and what we reach in terms of assurance and confidence on the system development is fully mastered in a clear operational domain definition. That's the second point, strict boundaries for operational context. The system must operate within strict limits to ensure safety and reliability. And that's within, let's say, that brings us to have the system working within the boundaries, possibly having contingency management outside of these boundaries, but yet within the boundaries, we have uncertainty to manage. AI, some approaches like machine learning are statistical approaches. We are dealing with a level of uncertainty that sometimes is a bit beyond what we were managing in traditional system development. And we have to think about the concept of independent system that would be required to perform at level 3 an oversight. I would say emulating the monitoring and decision-making that a human would provide in equivalent conditions. After, you can say, yes, but there are some operations, like what you show on the screen, that are not involving necessarily a human. Here, I kept a human operator. You could think use space. Who, as an operator, would like to monitor and would be capable of monitoring extremely rapid decision-making of a use space management system? That's something questionable. So we may have cases definitely where, it is the operation that actually size the level. It's not a continuous process to try to get to level 3. It's more a level 3 challenge and ConOps that is brought to us. That's why we are developing all what we've developed. One challenge, thinking about removing completely the human and having an operation like of such a nature without human in the loop, is directly embedded in the Article 14 of the EU AI Act. That's something we keep carefully also in mind. The AI Act really mentions clearly that oversight and control is necessary for high-risk systems in their operations. That's pretty clear, but after, the way and means should be commensurate to the safety case, to the ConOps, etc. And this is exactly the way in which we are evolving to develop something that would be feasible, yet remaining in under safe conditions. So that moves us to the last part of my talk, which is about the rulemaking tasks and activities that have already started this year, because we entered in the consolidation phase of the roadmap. So this concerns level 1 and 2. Definitely level 3 is still an exploratory and exploration part of the AI roadmap. So we prepare here a dedicated part AI, first to establish the generic AI trustworthiness principles and framework in response to the mandate that is given to us by the EU AI Act Article 108. Based on that, we will, in a second phase and step of the rulemaking task, prepare the safe deployment of this generic framework into the different domains that are impacted. You saw a glimpse of them in the examples that I chose for the talk. And the terms of reference of the rulemaking task have been published as foreseen before the summer this year. And we have already started with the rulemaking group, and some of you are part of it. We have started preparing the first NPA, which the Notice for Proposed Amendment, which is foreseen for early summer 2025. In parallel, we carry on working closely with our industry and all the stakeholders to rigorously identify, test, and why not certify, at least for the lower levels, AI technologies. And by learning also from other sectors, we have standardization activities starting for the AI Act everywhere, I would say, in automotive, in medical, in railway, and we can benefit really all together from the knowledge and the findings, insights from everyone. So we are closely connected also to this activity. Two things that I didn't mention, but that are extremely important. So I started mentioning the safety benefit needs to be taken into account. This is something we will embed in the rulemaking task. let's say, taking also inspiration from the notion of net safety benefit that is already available in general aviation. And the other thing I didn't mention, the AI trustworthy tools. So AI is not necessarily a certified component of an embedded in a product. It can be a tool used operationally by an organization. And that's a crucial element that is, let's say, accelerated, of course, with the large language models, all what we see available from a generative AI perspective. So that's a COTS, let's say, commercial of the shelf thinking that goes a bit beyond the fence of what we know how to manage today. That's another element to be embedded. So I hope I gave you let's say, an overview of first where we are, where we go, what are the big concepts and the underlying challenges. That was the goal here of my talk. What you see is technology is clearly, let's say, the driver. The human is at the center, and that's really what we want to keep. And we get new concepts. That's why we have to think also differently, possibly, but keeping the reference point we have today, which is the safety case with the human in the loop, and that's extremely important to manage safety and safe deployment of AI. Thank you for your attention, and don't hesitate to engage if you want. Thank you.